from number 1 to 8, and how many can you be able to solve from all this list of questions. So this is what we want to start here. So from here, let's start solutions. So I want to start solving from number 1. So this is number 1 question here. Number 1 question here. 2 raised to the power of 100 minus 2 raised to the power of 98 minus 2 raised to the power of 97 equals what? Now let's put it down here. So we have 2 raised to the power of 100 minus 2 raised to the power of 98 minus 2 raised to the power of 97 equals what? Now what's the first thing we want to do? Now we have like multiple ways or different ways of solving it, I would say. And so what's the first thing we are going to look out for? So the first way we are going to look out for is like separating. So we are going to separate this like this, and when we separate, what are we trying to see? What is common here in 2 raised to the power of 100 and 2 raised to the power of 98? So you can see that from here 2 raised to the power of 98 is common, right? And when it's common here, when we bring it out from here, here gives us 2 raised to the power of 2, right, minus 1, right, and minus 2 raised to the power of 97. So from here we have 2 raised to the power of 98 times 2 squared is 4. 4 minus 1 gives us 3, right, and minus 2 raised to the power of 97, right? So from here, what's the next thing to do? So from here we can see 2 raised to the power of 98 to be, we can bracket it, 2 raised to the power of 98 to be 2 raised to the power of 97 plus 1, right? 97 plus 1 times 3, and we have this one here minus 2 raised to the power of 97, right? So now let's do this. So when we have a, if you know, remember when we have a raised to the power of m times a raised to the power of n, it will give us a raised to the power of m plus n. Now it's as if we're having a raised to the power of m plus n, we can turn it to a raised to the power of m times a raised to the power of n. So this will now give us 2 raised to the power of 97 times 2 raised to the power of 1 times 3 minus 2 raised to the power of 97, right? So from here, what's the next thing that we're going to do? So from here we can see 97 common here and here. So when we bring out 92 raised to the power of 97, 2 raised to the power of 97 is common here and here, sorry. When we bring out 2 raised to the power of 97 from here, it leaves us with 2 times 3 here is 6, 6 minus 1. When we bring it out from here, it becomes 1. So 2 raised to the power of 97 multiplied by 6 minus 1 is 5. So this becomes our answer for this question here, for this number 1 question. Number 2 question, this is number 2 question here. 4 over 9 and 11 over 25, which is larger? This is quite simpler. Number 2. Now the second one. 4 over 9 and 11 over 25. How do we know the one that is larger in this case? So first of all, we'll just take this and this, we'll multiply this, and we'll take this and multiply this. So from here, 4 times 25 gives us 100, and from here 11 times 9 gives us 99, right? So from here you can see 11 is greater than 99, so definitely this fraction here is greater than this fraction. So 4 over 9 is greater than 11 over 25. That's easy, right? So for the third question, this is the third question here. We have 8 raised to the power of 9 plus 8 raised to the power of 9 plus 8 raised to the power of 9 plus 8 raised to the power of 9. This is also simple. So let's go. We have number 3. Let's do it here. So 8 raised to the power of 9 in 4 places. 8 raised to the power of 9 plus 8 raised to the power of 9 plus 8 raised to the power of 9 plus 8 raised to the power of 9. Now you can see 8 raised to the power of 9. We can factorize 8 raised to the power of 9 out. And when we factorize it out, 8 raised to the power of 9, right, we'll have 1. When we bring it out from here, it becomes 1. When we bring it out from here, it becomes 1. When we bring it out from here, it becomes 1. When we bring it out from here, it becomes 1, right? Good. So from here, we have 8 raised to the power of 9 multiplied by 4, right? So from here, 8 raised to the power of 9 is 8 is 2, right? Raised to the power of 3, right? You know that. And 4 is also 2 raised to the power of 2. right? So 2 raised to the power of 3 raised to the power of 9. This 9 is still there. So from here we have 2. When we have a raised to the power of m, right? A raised to the power of m raised to the power of n, it will give us a raised to the power of mn. Why? Because we are going to multiply these powers. So from here we'll multiply this power. 3 times 9 is 27. 27. So from here we have 27 times 2 raised to the power of 2. Now also note that when we have a raised to the power of m times a raised to the power of n, it will give us a, since they have the same basis, we'll have a raised to the power of m plus n. So that is what this one will give us 2, right? It will give us 27. Since we have 2, 2, it will give us 22 raised to the power of 27 plus 2. So our answer is giving us 2 raised to the power of 29, leaving us with our final answer here. So the next question, which is number 4, is this one: 4 raised to the power of 10 plus 4 raised to the power of 10 plus 4 raised to the power of 10 plus 4 raised to the power of 10. Now let's solve this here. Number 4, the fourth question, let's solve it here. So we have 4 raised to the power of 10, right, plus 4 raised to the power of 10 plus 4 raised to the power of 10 plus 4 raised to the power of 10. Right, from here we have, when we bring out 4 raised to the power of 10 out, we have 1, 1, 1, 1. Right, when we factorize it out from here, we have 1. When we factorize it from here, we have 1. When we factorize it from here, we have 1. When we factorize it from here, we have 1. So we have 4 raised to the power of 10 multiplied by 4 raised to the power of 1. Right, so from here, what we use for this place, the law we use for this place, when we have a raised to the power of m times a raised to the power of n, to give us a raised to the power of m plus n, because of the bases are the same. So for this other one, since the bases are the same here, 4 and 4, so it will give us 4, that's a raised to the power of m plus n, 4 raised to the power of 10 plus 11, right? Leaving us with 4, 10 plus 11, 10 plus 1, 10 plus 1. So leaving us with 4 raised to the power of 10 plus 1 gives us 11. So this will be our final answer for this number 4 question, right? How about this number 5 question here, if you can go about it? 15 factorial divided by 17 factorial minus 16 factorial. This is quite, I will not say it's difficult, but it's quite challenging. So let's go about it. So 15 factorial, so we have this one, 15 factorial here, right? So we're going to do it now. Sorry, 15 factorial. Let's do it here. So we're going to copy this question here, this one here. 15 factorial divided by 17 factorial minus 16 factorial. So let's copy that with question 5. Right? Question 5. 15 factorial divided by 17 factorial minus 16 factorial. Now, what is the first thing we're going to do? So now we know that factorial, if we have a factorial, what is it giving us? It will give us a times a minus 1 times a minus 2, and so on and so forth, right? So 15 factorial, we'll just have 15 factorial first, divided by, so 17 factorial is 17 times 16 factorial, right, minus 16 factorial, right? So from here, what do we have? So from here, we have 15, from here we have 15 factorial divided by, now we have 16 factorial here and 16 factorial here. When we bring it out 16 factorial, when we bring it out from here, we have 17, and when we bring out 16 factorial from here, we have 1. So that's minus 1. So our answer now becomes 15 factorial divided by 16 factorial times 17 minus 1 is 16 times 16, right? So from here, what's the next thing that we're going to do? From here, we have 15 factorial divided by, now 16 factorial. What's 16 factorial? 16 factorial is 16 times 15 factorial, right? And we also have times 16 here, right? So from here, 15 factorial, we have 15 factorial divided by 16. We can bring it 16 times 16 times 15 factorial, right? So from here, we can have 15 factorial over 16 times 16 gives us 324 times 15 factorial. So from here we can see 15 factorial cancels 15 factorial, right? So our answer is now 1 over 324, right? Good. So the next one is this number 6 question we have here. Number 6 question here, which is 60 raised to the power of 40 divided by 30 raised to the power of 20. 60 raised to the power of 40 divided by 30 raised to the power of 20. So let's go. How do we do that? Number 6 here. 60 raised to the power of 40 divided by 30 raised to the power of 20. Now this is quite easy. So for now, we're going to have 60 raised to the power of 40. What will it give us? So from here, 40, so we can have 60 raised to the power of 20 plus 20, right? So 40 is 20 plus 20, right? Divided by 30 raised to the power of 20, right? So what's the next thing we can do here? So from here we see that 60, when we have a, like I said earlier, when we have a raised to the power of m times a raised to the power of n, it will give us a raised to the power of m plus n. Now here we are having something like a raised to the power of m plus n. It can also give us a raised to the power of m times a raised to the power of n. So remember we have 60 raised to the power of 20 times 60 raised to the power of 20. Before this will now give us 60 raised to the power of 20 plus 20, and what we have here. So I've broken that one, separated it. So from here we have divided by 30 raised to the power of 20, right? So from here you can see raised to the power of 20, 20, 20. So what can we do, and what are we going to do in this situation? So from here we can see 60 raised to the power of 20 times, so with this 60 raised to the power of 20 and 30 raised to the power of 20, we'll bring it together, 60 over 30, because of they are all raised to the power of 20, raised to the power of 20, right? Good. So from here we have 60 raised to the power of 20 multiplied by 60 divided by 30 is 2 raised to the power of 20. Now here we can see the powers here the same. What do? We'll multiply. 60 times 2 gives us 120, and we'll have our raised to the power of 20, giving us our answer to this question here, right? Giving us our answer to this question here. Now the 7th question that we're going to take today, the 7th question is this. 10 plus 28 divided by 2. 10 plus 28 divided by 2. 10 plus 28 divided by 2. Now doing this with our scientific calculator, it will add it straight. If you do this with your scientific calculator, it will do it straight, meaning 10 plus 28 divided by 2, just the way you typed it. But doing it with normally with our brain, it won't give us that. It won't give us the same answer with our scientific calculator, right? Because our scientific calculator don't use what? BODMAS. So but we are going to use the BODMAS principle, which is the bracket of division, multiplication, addition, and subtraction. Now, what is it trying to say? Bracket of division, meaning anyway we find a problem like this, we'll take the division first before multiplication. That's if there is, and then addition and subtraction, right? So here we can find only division and addition. Division comes first before addition, so we'll take this one first. So we have 28 divided by 2 is 14. Then we have 10 plus 14. So 10 plus 14 gives us 24, right? So the answer for this is this, right? So the 8th question, which is the last question we're going to take for today, is this one here, number 8 question. Square root of 10 raised to the power of 20 over 50 raised to the power of 10. Now let's do this. We have here number 8, the last question we're going to take for today. Square root of 10 raised to the power of 20 divided by 50 raised to the power of 10. Now this is very simple. The first thing we're going to do, right? Don't forget, when we have square root of a over b, it can also be the same as root a over root b, right? That's what we're going to do here. So we'll separate the square root, meaning we'll have root 10 raised to the power of 20 over root 50 raised to the power of 10, right? Good. So from here, when we have also another law, so this is just a law, another law, when we have square root of a, right? When we have square root of a, it's still the same as a raised to the power of 1 over 2, right? When we have square root of a, it's still the same as a raised to the power of 1 over 2, right? So from here, what's the next thing we're going to do? So we have square root of 10. It is the same thing as 10 raised to the power of 1 over 2. So we have 10 raised to the power of raised to the power of 1 over 2 multiplied by 20, that's power 20, over, this will be the same 50 raised to the power of 1 over 2 times 20, right? So from here, what do we have? So from here, when we have another law here, when we have a raised to the power of m times n, like a raised to the power of m raised to the power of n, it will give us a raised to the power of mn. Why? We multiply the powers here together, right? So from here, we multiply these powers. You have 10 raised to the power of 1 over 2 times 20 over of 1, right? So 10 is 50 raised to the power of 5, right? Good. So from here we can see that when this law where we say a raised to the power of m plus n, here we said it here at this place, a raised to the power of m times a raised to the power of n is equal to a raised to the power of m plus n, right? So from here we have 10 raised to the power of 5 times 10 raised to the power of 5. That's what will give us 10 raised to the power of 5 plus 5 divided by 50 raised to the power of 5, right? So from here we have 10 raised to the power of 5, right? Let's put it here, times 10 raised to the power of 5, or we can say 10 times raised to the power of 5 times 10 over 50, all raised to the power of 5. We can just cancel this one and put it there, all raised to the power of 5, because since this is raised to the power of 5 raised to the power of 5, we can put it together. So from here we have 10 raised to the power of 5. For here we have 10 raised to the power of 5. Let's bring it here. We have 10 raised to the power of 5 here, right? We have 10 raised to the power of 5 times, so for this place 10 cancel, 10 here 1, 10 in 55, so we have times 1 over 5 raised to the power of 5, right? So since you have root 5 here in this place, so we can join it together and say 10 times 1 over 5 all root 5, right? So from here 5 here 1, 5 here 2, 2 times 1, so we have 2 raised to the power of 5 as our final answer. And if you want to get the original value of 2 raised to the power of 5, that's 32, right? So this is our answer for this question here. So this brings us to the end of solving all these questions here. This brings us to the end of solving every single question, all these questions. So please don't forget to like the video, subscribe to the channel, and don't forget to leave your genuine thoughts about this video. Thank you very much.